pre-calculus. I'm sorry I'm not able to be there with you today, but this is what we would have gone over together if I was there in class with you. Okay, so I would like for you to get a little introduction into using interval notation. This is what we're going to start using, so let's go over this. First of all, you're going to use parentheses for open. Parentheses means that these values right here, the values, okay, are not included. Not included. So that means that if this was a 4, the graph or the equation is not using the number 4. Okay? Brackets are for closed. Okay, so the value, if this was a 5, okay, this value right here would be included. It would be included, it would be used. The picture is going to be a closed bubble when you graph. Okay? And then most importantly, we always use parentheses on infinity. So from parentheses negative infinity, comma positive infinity. Remember, it always goes small, comma big. Okay? You can't actually get to infinity because it's forever. You can't get there, you can't touch it, so we're going to put a parentheses on it. Okay, so what I would like to do now is look at these graphs and write them in interval notation. Okay, interval notation looks kind of like a mini graph. So I notice here that negative 10 is being used and that the graph goes completely to the right with the arrow highlighted, and that indicates positive infinity. Okay, since this is closed, we're going to use brackets from negative 10 all the way up to infinity. And what symbol did we say always goes on infinity? That's right, a parentheses. Okay, and that's it. That's how you write your answer in interval notation. Okay, just to kind of explain what we're doing here. If I were to say x is greater than or equal to negative 10, this would be inequality notation. Inequality notation. But what we're going to start doing in pre-calculus is using interval notation. So if the directions say write your answer in interval notation, that's what they're talking about, the brackets and parentheses. All right, I noticed that this example here has 2 pieces of graph, which means we're going to have 2 sets of intervals. Okay, but remember, we always start at the left and go small to big. Okay, so right here, this is negative infinity, and this is negative 6. Okay, but that's an open bubble. He kind of looks like a parentheses, doesn't he? Okay, and remember, infinity always gets parentheses. So this first little piece is parentheses, negative infinity, all the way until we get to negative 6 with parentheses. Okay, oh, but hang on, there's another piece. Okay, and so the symbol for and is union. Okay, so union is kind of how we say, and another piece is coming. Okay. This piece starts right here at 6 and goes all the way forever with an arrow. So that's going to be positive infinity. Okay, since this is filled in, that's going to get a bracket from 6 to infinity with parentheses. Okay. 2 pieces of graph, 2 intervals. They kind of look like a little shading graph, don't they? Number 3, 2 pieces. Okay, so let's start from left to right. This section right here goes all the way to negative infinity. Negative infinity always gets a parentheses, and it goes all the way until the value 1, 2, 3. Since that's filled in, we're going to do a bracket. Okay, and then that symbol for and another one. Okay, so we use the U, the tall union symbol. We start at 5. Okay, since it's filled in, that's a bracket, and it goes all the way to positive infinity. Infinity always gets a parentheses. Okay, number 4. I'm noticing there's 2 pieces. Let's start at the left side. Negative infinity always gets parentheses and goes all the way. This is negative 1. Okay, since negative 1 is being used, okay, it gets a bracket. Oh, there's another piece, so let's use the union symbol again. We're going to start at 1, 2. This is a value of 2. Okay, 2 is open. It's not being used. Okay, so we use a parentheses, and it goes all the way. This is the positive infinity side. Infinities always get parentheses. Okay. A lot of people tell me they like interval notation. It's a little easier to write. Number 5 is a little different. Okay. I noticed that a lot of this graph is shaded except for one value. Okay, so we're going to start on the left-hand side with negative infinity. Negative infinity is going to get parentheses, and it goes all the way until 0. We're going to have to put 0, and since it's open, we're going to put a parentheses. But there is some more shading. Okay, so we're going to have to union another section. Now the question is, where does this section start? We're going to start right at 0. Right at 0 with a parentheses. Some people say, well, why don't we start at 5 with a bracket? Why are we starting here? We don't want to forget about the values 1, 2, 3. You have to start right where the hole is. And we're going to go all the way to positive infinity with a parentheses. Okay, so what's interesting here is we just showed you, okay, right here, this is how you write a hole. How you write a hole. You stop at 0, you start at 0, but since you used parentheses, 0 is not being used. 0 is not being used. Okay, but we used everything except for the 0. Kind of cool, right? Okay. Let's go apply this knowledge to a problem in the back of your packet. This is page 57. So please go turn to page 57. Okay, and we're going to find the domain for this equation. First thing I noticed, there is an expression under the radical sign. So let's write down the expression. An expression under the radical sign, what's the domain rule for that? Greater than or equal to 0. Okay, now there is a quantity squared. Okay, so we're going to have to go ahead and factor this. We're going to factor this into 3x plus 2, 3x minus 2, which is greater than or equal to 0. Okay, since we have a couple different values, the way that we're going to do this is a number line. Okay, so when we have a squared power, let's just write down over here, when do we have to do the number line? Okay, when we have x squared. Okay, so when x has a power, it's higher than a linear, like if it was a cubic also, okay, when it has a power. You also have to do the number line when you have the inequality sign. The inequality sign, that's the greater than or equal to sign. These are the inequality signs. If you have these two things, you have to draw the number line. You don't have to do this if it was a not equal sign, because you could just square root. Okay, but if you have these two situations happening, we have to draw the number line. What numbers are going to go on the number line? Okay, so if you need to solve these little things, 3x plus 2 is equal to 0. Negative 2 divided by 3. So we've got negative 2/3 as the first value and positive 2/3 as the second value. Now, are these bubbles going to be open or closed? Since it's an equal sign, okay, we're going to be able to include them. So we're going to fill them in. Okay, and now what's the next step? Okay, I don't know where the answers are, so we're going to have to test the sections. Okay, so let's test. Let's find a number in this section to test something smaller than negative 2/3. Maybe I'll do, I don't know, we could do -1. If that's cutting it too close, -5. Let's just do -5. Okay, so if I put -5 in for the x, -15 plus 2, that's going to be a negative. -15 minus more, that's a negative. So this section is working out to be positive. That's what we wanted. Okay, so please color this in. Make sure you show me the testing. Show me the answer with the shading. Okay, I don't know where to shade until I test. All right, in this middle section, ooh, the nicest number would be a 0, right? 3 times 0 plus 2 is positive. 0 minus 2 is negative. This section is working out to be negative, and that's not what we want. Third section, I'll go ahead and test. How about 10? Okay, clearly definitely bigger than 2/3. 30 plus 2 is going to be positive. 30 minus 2 is positive. This section, positive times positive, is positive, and that's what we want. Okay, so right here, we wanted positives. The equal sign was taken care of with the colored in circles. The positive comes from the section, okay, and this is all beautiful work. Okay, but now we're going to write our answer. And I'm going to use that new notation that we just learned. Okay, so let's go ahead and write our answer in interval notation. Interval notation, okay, which is how we're going to start writing all our pre-calculus answers. So my first section right here, okay, goes from negative infinity, always gets a parentheses, until negative 2/3. Since it's filled in, we get a bracket. Okay. Oh, and some more. So the symbol for and is, that's right, a U. We're going to start with brackets, 2/3 until infinity. Okay. So there's our answer to solving for the domain. So the domain is going to be this. These are the numbers that work, the inputs that are going to be able to go into this function. Thanks, guys. Good luck with your video tonight.